Multithreading is one of the critical and hardest topic in Java. But believe me, this will be very interesting topic if you understand it well. You might have come across the terms like concurrency, parallelism, process, task, threads, locks, etc. But still you might have few queries on these terms or you are not 100% sure with these terms. If you are in this situation, you are at the right place now. Today we are going to explore these basic terms in our introductory episode of the multithreading series. If you're visiting the channel for the first time or not yet subscribed, please subscribe to the channel and stay tuned for the visualized coding tutorials. Let's dive into the topics without making any further delay. We'll start with understanding the term concurrency using a small analogy with restaurant. Imagine there is a startup restaurant with 2 chefs, 1 waiter and 3 tables. Whenever a table is occupied with the customers, waiter will come and takes the order, right? Then he will pass the orders to the chef and he will wait there until the items were ready or prepared. Now imagine while waiter is waiting for the food at the chef counter, other 2 tables got occupied. And the customers at these newly occupied 2 tables should not wait for a long time and it's a bad experience for the customers, right? This is where concurrency comes into the play. Instead of waiting ideally for the first table at the chef's counter, waiter can go to the other tables and he can take the other orders too. So that at the same time, the customers at the other table can give the order and the other chef also prepare the food, right? So here the situation is we have only 1 waiter in the restaurant but he is handling efficiently all the 3 tables without any ideal waiting. This is known as concurrency. Let us say the 3 tables 1 to 3 has serving time T1, T2 and T3. So the total time serving for the waiter is sum of these 3 T1 plus T2 plus T3, right? But here the total time served is less than that sum because here the waiter didn't wait anywhere ideally. He used the time efficiently. I hope now you are clear with the term concurrency. Now let's explore one more important term in multithreading called parallelism. To understand this, we will take the same analogy of the restaurant. Now say the restaurant has some good profits and the restaurant manager wants to hire some more waiters and chefs. Let us say now he has 3 chefs and 3 waiters in the restaurant. Which means now each table has its dedicated waiter and the chef, right? So now the moment a table is occupied by a customer, the respective waiter will go and takes the order and delegate it to the respective chef. So here in this case, each waiter working simultaneously without depending on other waiter or other chefs, right? They have dedicated tables and dedicated chefs and the tasks were going parallelly. This is what parallelism is and it is more efficient than concurrency because here more resources are available to accomplish multiple tasks. I hope now we are in a situation to understand what is concurrency and what is parallelism. Let's revise one more time both the terms so that you will be clear with. Concurrency deals with doing multiple tasks by switching between them efficiently, that is context switching. And concurrency can happen on a CPU even with a single processor. Whereas parallelism doing multiple tasks at the same time or simultaneously and it needs multiple processors or CPU cores. In our restaurant examples, we can treat waiters or chefs as a processors or the CPU cores. So this is all about the important terms concurrency and parallelism. Now let's quickly explore the remaining terms, that is process, task, thread and locks. And to understand these terms quickly, again I am taking the same restaurant example. A process is like a restaurant, that is all the activities going inside a restaurant can take it as one process. And then coming to the task, it is a unit of work like taking orders, serving dishes or billing the customers. Coming to threads, inside the restaurant you have waiters, right? These are your threads. Each thread performs different tasks but share the same space and resources. And coming to the final term, that is locks. Suppose you say there are limited chefs available in the restaurant like our concurrency example. So then there is a chance of chaos at the kitchen counter with multiple waiters, right? So to prevent this chaos, we can put a rule or a lock that is only 1 waiter can access it at a time. So coming to Java, whenever a Java program is executing in the memory or we can say CPU memory, it will hold the CPU cores, right? So that will hold the CPU cores through these threads only. So there also high chance that one thread can try to access a CPU core which is already accessed by other thread, right? This can cause that our program can give a unexpected output, right? So to prevent this, Java also providing a lock mechanism to operate on our threads. For now, you can just keep this in the mind. So later whenever we demo through the programs, you will understand the terms better. So that is all about in this episode. In our next episode, we will go through concurrency in Java with respective CPU cores. To get notified on our upcoming videos, please subscribe to the channel if you're not yet subscribed, and see you in the next.